We shall continue with some problems. This problem says that implement McCulloch-Pitts neuron model for following, and we are given an equation, we are given a logic function, and that logic function is indicated as OK plus 1 is equal to x1 raised to k, x2 raised to k into x3 bar raised to k. So now this k and k plus 1 you just have to ignore. In simple word, it will mean that you are given, in simple words, it means that O is nothing but x1, x2 and x3 bar. The k will indicate that, it will just indicate the stage. So when it is k plus 1, it means that there will be only one neuron in this particular model. So we start with the truth table for the equation. Everybody knows to draw the truth table. So we have to take x1, x2, x3 because there are 3 inputs, and then we have to calculate net, and then we have to calculate O. So we have taken the 3 input truth table and we know this particular equation. So according to that, we will know that when the output will be 1. Now this equation is x1, x2, x3 bar. So output O will be high only when this is 1, this is 1 and this is 0. So only when x1 is equal to 1, x2 is equal to 1 and x3 is equal to 0, the output will be 1. So we know that O will be 1 when x1 is equal to 1, x2 is equal to 1, x3 bar is equal to 1. That means that x3 should be equal to 0. So I write the output. It will be only for this particular condition, that is 1, 1, 0. This particular condition, the answer will be 1, and rest all the output will be 0. So I have to combine it. The net should be such that it should be greater than the threshold only for this particular condition. So how will I take net and how will I select the weights? That is what is the question. So since there are 3 inputs, we will be taking a neural network which is made up of 3. So we have a neural network which is made up of 3 inputs, x1, x2 and x3. We have to decide what will be the weight. The output is O. And we have to decide what will be the threshold. We have to decide the weights and we have to decide the threshold. Now as you know, in case of McCulloch-Pitts neuron model, you can have weights as plus 1 and minus 1. You cannot have anything else besides that. So how we decide is that if at all you see this x1, x2 and x3. So what we want is that we want the output to be high only when x1 is equal to 1, x2 is equal to 1, x3 is equal to 0. So for x1 and x2, I will give excitatory weights, and for x3 I will be giving inhibitory weights. And inhibitory weights is nothing but minus 1. So W1 and W2 I assign plus 1 and W3 is minus 1. So based upon this I can calculate net, and what is net? Net will be x1 plus x2 minus x3, and that net will be coming over here. And this net has to cross the threshold for 1, 1, 0 condition. So if at all we calculate the net, in first case then it is 0, 0, 0, net is 0. When it is 0, 0, 1, net is minus 1, it is 1, again it is 0. You can complete the table in this particular way, 1, 0. Only in the third case you get net as 2, and in the last case you get net as 1. You can calculate that. So now we want the input to be high only for this particular condition. So what should we select the threshold as? Looking at this itself, we can come to know what should be the threshold. So looking at this only, we can come to know what should be the threshold. Threshold is selected as t is equal to 2. So I can select the threshold as in macular pitch neuron model, we take only whole numbers, but otherwise the threshold can be selected as 1.5 also. So anything which is above 1.5, the output will be high. So 2 is anyways greater than 1.5, so the output will be high for that particular case. Okay, so the threshold is selected in this case as 2. Okay, so I hope why threshold is selected as 2, it is clear to you all. So this is the neural network which is you have designed finally for this particular problem. Problem number 2, this is the second problem B, where you are given a different equation, and this equation you have to, this is the equation which is given to you. The same way you have to complete the truth table, and accordingly what you have to do is that select W1, W2, W3 and find what is the threshold. So this I expect you all to solve this problem, and we shall go to the next problem. Now this is the third problem which is given to us, and it is slightly different. Here we are told to use OK plus 2. So when we are using OK plus 2, by this you can come to know that it should be a two-stage network. Okay, so it should be a two-stage network. So when it is a two-stage network, what we have to do is that we have to use two neurons. So one particular way of doing this is that there may be more than one ways to solve the problem, but one particular approach which I am telling you is that what you all can do is this way. In digital system design, maybe you all have done a similar thing. So you can write this equation with double bar. So you can, to simplify, I just write it as O as x1 bar, x2 bar, x3 bar, and the whole thing is double bar. So when I put a double bar, it is nothing but same as without a bar. So we know the De Morgan's theorem, and we can, this split, and what would I get is that the outer bar will still remain. This will become x1 plus x2 bar plus x3. If at all, so basically what has happened is that I have got this. So this equation is a whole bar. So I can write it as this is your OK plus 2. So this OK plus 2, you can keep the K if at all you want, it will be nothing but this. I can write it as OK plus 1. So this I can write it as OK plus 1, the whole bar. So what we would be doing is that we would be first finding OK plus 1, and then we would be finding OK plus 2. So for doing that, we first calculate net 1 and O1. And what would be net 1? Net 1 would be based upon what we had here. So this equation, first we would be finding OK plus 1, and I just ignored K. K is assuming that K is equal to 0. O1 will be nothing but x1 plus x2 bar plus x3. And then what will be O2? O2 will be O1 the whole bar. So this is the simplified way of doing this. So now here it is not the, this is sum of products form in this particular case, so it is slightly different. So the output should be, now this should be, the O1 output should be high either when x1 is equal to 1, or when this is equal to 0, or when this is equal to 1. So when x1 is equal to 1 or x3 is equal to 1 or x2 is equal to 0, these particular cases the output will be. So we see when x1 is equal to 1. So whenever x1 is equal to 1, these four conditions output has to be high. Whenever x2 is equal to 0, these two conditions output has to be high, and whenever x3 is equal to high, these three conditions the output has to be high. So which is the condition which is left out? There is only one condition which is left out, that is this one, and so only for this particular condition 0, 1, 0, the output will be 0, and for the rest of the conditions the output will be high. If you all have not understood this particular thing, you can draw K-maps and also find out the output. So the choice is yours, how you will be doing it. So this is this is your sum of products term. Okay, this is this is SOP form, sum of product form, but it is not the sum of the midterms. These are not midterms, but you can get it in the sum of midterms form. So we want the output to be high for all these cases. So in the previous, what we had done is that here x1 is positive, x3 is positive, x3 is negative. So what we shall do is that in the same way, W1 I can assign as positive weight, W2 negative weight, W3 I assign again positive weight. So what will be my net calculation? Net 1 calculation will be x1 minus x2 plus x3. How we get this? This we get from the fact that net 1 is nothing but x1 w1 plus x2 w2 plus x3 w3. So w1 is 1, w2 is minus 1, w3 is minus 3. So we get this particular equation. So we will be writing net values. So in the first case it is 0, second case it is 1, third case it is minus 1, 0, 1, 2, 0 and 1. So looking at this, after calculating the net, now tell me what should be the threshold. Now the threshold should be such that the output should be high when for all these conditions except for this condition. So the threshold which is selected here will be t is equal to 0. So 0 is less than or equal to the threshold, 1 is greater than the threshold, minus 1 is less than the threshold, so the output is 0 here. 0 is equal to the threshold, so output is 1, 1 is greater than the threshold, so output is 1, 2 is greater than the threshold, so the output is 1, 0 is equal to the threshold, so the threshold is 1, 1 is greater than the threshold, so the output is 1. So I hope it is clear how to select the threshold in this particular case. So now it is not done. We have to do the, depending upon what we have got here. Now threshold is equal to 0, and this is x1, x2, x3. This is the weights will be 1, minus 1, 1. So now this is not done. We have to still consider what will happen after this. We have found out till O1. So after O1, this particular output which is there, O1, it is given to one more neuron, because this is the first neuron and there will be one more neuron. So what should be the weight given for that particular neuron? That now O2 is nothing but O1 bar. So what we take is that beside that the weight which will be used here will be -1. So now our next task is to find out what is net 1 and next step is to find out what is net 2. Now what I told you is that O1 output is given to this particular neuron. So this will be the second neuron which will be there, and the output of that will be O2. Now O2 is equal to O1 bar. So when it is O1 bar, the weight we should give is a inhibitory weight. So that weight is assigned, and based upon that we have to calculate what is net 2. So what will be net 2? The equation of net 2 will be nothing but minus of O1, because O2 is nothing but O1 bar. So we consider net 2 as minus of O1. So what we do is that we find out what is net 2. So I'll use this. So this will be -1, -1, 0, -1, -1, -1, -1, -1. Now, according to this, now next we have to find out what is O2. So what should be the threshold for O2? See, output O2 is nothing but O1 bar. So O1 bar is nothing but this, the whole bar. So it should be the opposite of this, 0, 0, 1, 0, 0, 0, 0, 0. So wherever O1 is equal to 0, that particular place O2 should be equal to 1. So now looking at net and looking at O2, we can find out what is the threshold. So only for this particular condition, the output should be high. So what should be the threshold selected? The threshold selected should be 0. So here the threshold T2 should be equal to 0. That is, T2 is nothing but threshold of the second neuron. So T2 I can write it as equal to 0, whereas T1 is equal to also 0. So we have been able to successfully design one more network, and this here you will be getting the output OK plus 1, and here you will be getting the output OK plus 2. Okay, but since we are considering x1, x2, x3, that is K is not considered, so we will be getting O1 and O2. But why I have taken here in the question K is because there is unsolved problems from behind the textbook. So if somebody just takes those problems from behind the textbook and asks the exam, then you should not get confused with K. Is that clear? So if at all you have any doubt, you can let me know about this. Okay, we'll have a look at the next problem. The next problem given to you is OK plus 2 is equal to x1 raised to k into x2 raised to k. So in simple form it will be O2 is nothing but x1, x2. So similarly what we have to do is that take double bar. So it will become x1 bar plus x2 bar, and this will be O1 bar, where O1 is equal to x1 bar plus x2 bar. So using this you can solve this problem. This is just the hint which I have given you. Fine. So these kind of problems are now done.